Can you solve this problem? At 8 o'clock in the morning, a ship began to leak at a constant rate. The crew members only discovered the leak some time later. By then, there was already some water in the ship. If you turn on one water pump at that time, pumping some water outside the ship will be full of water and sink at 10 o'clock. If you turn on two identical pumps, then the ship will be full of water and sink at 10:20. If you turn on three identical pumps, the ship will be full of water and sink at 11 o'clock. In order to keep the ship from sinking, at least how many water pumps should be turned on? Each water pump pumps water out of the ship at a constant rate. Try this problem for yourself, and when you're done, come to look at this for the final solution. The solution will appear in 3, 2, 1. Now, let us solve it. To solve this problem, we will assume that 1 unit of water leaks into the ship every minute. Then, we know that the total amount of water is equal to the boat of water that sank the ship, plus the water that was pumped out by the water pumps. This is very important. Let us analyze each case and use them to draw some diagrams. We will consider case number 1 first. In this case, the ship began leaking at 8 o'clock and sank at 10 o'clock. This is a difference of 2 hours or 120 minutes. We can represent all of the water as a line. We can chop this line up into 2 smaller segments. This segment represents the boat of water that sank the ship, and this other segment represents the 1 pump that operated from when the leak was discovered to 10 o'clock when the boat sank. The pump pumped out some water, and this second segment is what is represented. Now, let us consider case number 2. In this case, the ship still began leaking at 8 o'clock, but there were 2 pumps, and the ship sank at 10:20. This is a difference of 140 minutes. Again, we can represent the total amount of water as a line segment. Again, we can chop this line segment up into 2 smaller line segments. This segment represents the boat of water that sank the ship, and this segment represents the water that the 2 pumps operating from when the leak was discovered to 10:20 when the boat sank. This second segment represents how much water is pumped out by the 2 pumps. Now, let us rethink about case number 2. Instead of allocating the whole second piece of the line to the 2 pumps, we will split this segment. We will split the second segment into 4 smaller segments. These two segments each represent one pump operating from when the leak was discovered to 10 o'clock. These two line segments represent one pump that was pumped. These two line segments each represent the water that was pumped out by one pump for 20 minutes. We can combine these two literal line segments into the water that is pumped out by one pump after 40 minutes. Let us look at case number 3. We chop this second line segment into 4 smaller line segments. These 3 line segments represent one pump operating from when the leak was discovered to 10 o'clock when the boat sank each. Then we chop up the remaining piece into 3 smaller segments. We will not show it now, but the remaining piece will be 3 pumps for 60 minutes. This can be rewritten as one pump operating for 180 minutes or 3 hours. In summary, we have 3 cases. We will label them 1, 2, and 3, like this. Keep in mind that in case number 3, the 3 pump 60 minutes segment can also be rewritten as one pump operating for 180 minutes. Now take your focus to the left. We know that 1 unit of water goes into the ship every minute. In the first case, there are 120 minutes, so there are 120 units of water. In the second case, there are 140 units of water, and in the third case, there are 180 units. Now, let us compare the results we got. They will help us solve the problem. We will subtract case number 1 from case number 2. For reference, this is case number 1, and this is case number 2. This line segment represents the difference between case 1 and case 2, the green line segment. Case 1 and case 2 have 120 units and 140 units of water each, respectively. Then, one pump operating from when the leak was discovered to 10 o'clock, plus one pump operating for 40 minutes would be equal to 20 units of water. 20 comes from subtracting 120 from 140. We can do the same. We will subtract case number 1 from case number 3. This is case number 3, and this is case number 1. They have 180 units and 120 units of water, respectively. This green line segment represents the difference between the two. 2 pumps operating from when the leak was discovered to 10 o'clock, plus 1 pump operating for 180 minutes will be equal to 60 units of water. Again, 60 comes from subtracting 120 from 180. So, we will collect these two equations we have got. Now, let us multiply the first equation by 2. This will yield 2 pumps. Sorry, I forgot an S. Operating until 10 o'clock plus 1 pump operating for 80 minutes is equal to 40 units of water. Then we will copy the second equation down here. Now, these terms cancel nicely with each other. Then we subtract the first equation from the second. That yields 1 pump operating for 100 minutes is equal to 20 units of water. Then 1 pump operating for 1 minute will be equal to, yes, 1/5 units of water. The rate at which the pumps pump water must be at least equal to the rate at which the water leaks into the boat. Otherwise, the water in the ship will increase gradually, and the ship will eventually sink. We have assumed that water leaks into the ship at a rate of 1 unit per minute. Since 1 pump does 1/5 of that work in 1 minute, we will need 5 water pumps. Do you solve this problem correctly?